Hello and welcome to a video on volume word problems. Let's get started with number one. A set of three cylindrical canisters, so we know that cylindrical means cylinder, all have a diameter of 8 centimeters. So we're looking at the diameter and it's 8 centimeters. The height of the canisters are 16 centimeters, 12 centimeters, and 9 centimeters. So we have a height of 16, 12, and 9. Which of the following is closest to the total volume of the three canisters in cubic centimeters? So when thinking about this problem, we have a composite volume, right? Because we have cylinder 1 plus cylinder 2 plus cylinder 3. Well, the volume of a cylinder is the area of the base times the height. Well, the base is a circle, so we know it's going to be pi r squared times the height plus pi r squared times the height plus pi r squared times the height. Now we can start to plug in some values here. First things first, I know that pi is 3.14. I know my radius is half the diameter, so I know my radius is going to be 4. And the heights vary in each. So the height in the first one is 16. 3.14 once again. 4 stays the same. They each have a diameter of 8, so I know 4 will stay the same. And my second height is 12. And then I have 3.14 again, 4 again, and then my last height is 9. Now it's just a matter of crunching numbers. So if you don't know how to do a square, we're going to do 3.14 times 4 times 4 times 16. We get that number. Then we do 3.14 times 4 times 4 times 12. And then we do 3.14 times 4 times 4 times 9. When I run that through my calculator, I get 1,858.88. And these units are all in centimeters, so that's going to be centimeters cubed. Let's take a look at the second one. It says here, a rounded die is created by smoothing the corners of a plastic cube. The original cube has an edge length of 2 centimeters. The volume of the final die is 7.5 cubic centimeters. What is the volume of the waste generated by the smoothing of the corners in centimeters cubed? So essentially what we have here is we have our original cube that has a length of 2 centimeters, and then we have a new cube once the smoothing takes place. I guess that's the process of taking off those corners. So we have a subtraction problem. We have the original minus the new, and that's going to give me the volume lost. So in my original, they don't tell me what the volume is, but they tell me that the edge length is 2. So I know that to find the volume of a cube, it's side cubed, or length times width times height, but length and width and height all happen to be the same. And then we're going to subtract the new volume, which they did give me to be 7.5. Well, I know the edge length is 2, so if I do 2 to the third power, that's going to be 8. And 8 minus 7.5 is going to be 0.5 centimeters cubed. Okay, let's take a look at the next one. In number 3, we have Pam is making a party hat, shown below, in the shape of a cone for her birthday. The circumference of the base is 56 centimeters. If the height of the hat is 25 centimeters, which of the following is closest to the volume of Pam's hat, measured in cubic centimeters? So essentially what I have to do is I have to use this circumference to find the radius. And then so circumference is equal to 2 times pi times r. So what I have here is I know that the circumference is 56. I know it's 2 times 3.14 times radius. If I take 56 and I divide by 2 times 3.14, or 6.28, I'll know I get a radius of 8.92. Now that I have the radius, I can find the volume, right? They're looking for the volume of Pam's hat. So the volume of a cone is area of the base. So we have volume equals pi times the radius squared times the height, all divided by 3. Let's start to plug in our numbers now. Here, we have volume equals pi, 3.14, times the radius of 8.92 squared, times a height of 25, all divided by 3. Again, we're going to do in our calculators 3.14 times 8.92 times 8.92 times 25, all divided by 3. And when I do that, I get volume equals 2,081.99 centimeters cubed. All right, let's take a look at the last problem. In this last problem, we have an orange is in the shape of a sphere. Its volume is 904.8 cubic centimeters. What is the radius of the orange? So we need to go from volume and get radius. So we have to use a literal equation to get that. So let's write the volume of a sphere. Volume equals 4 times pi times the radius cubed divided by 3. Well, I can start to plug in some of these numbers. I know that the volume is 904.8. Then we have 4, we have 3.14, and I don't know what the radius is, so we're going to have to put a variable, and then divide by 3. So I start to reverse some of this, and I know the opposite of divide by 3 is going to be multiply by 3. So here I have 904.8 times 3 is going to be equal to 4 times 3.14 times the radius cubed. Now, again, I want to get the radius by itself. So I need to reverse times 4 and times 3.14. And when I do that, that's with division. So I get in my top here, I'm going to have 904.8 times 3. In the bottom, I'm going to have 4 and 3.14, right, because I'm dividing. And this is going to be r cubed. Well, when I crunch these numbers in my calculator, do 904.8 times 3, and then divide by 12.56, I get 216.12 equals r cubed. Well, we don't want r cubed, we want r. So in order to reverse a cube, we have to use a button on the calculator that looks like this. It's a cube root. So it may be in class I can show you all how to, where on your calculator this button is located. But in the meantime, we're going to apply a cube root on this side. We're going to apply a cube root on this side. And when I apply my cube root, I get 6 and r, and then cube root undoes the cube, so it's just r. So my radius is going to be 6 centimeters. There. So those are the 4 questions on the volume word problems. If you have any questions or you need additional help, feel free to send an email or ask a question in class. Thanks.